This problem is from rotational motion and covers the concept of angular momentum and elastic collision. So a bar is given and one end of the bar is pivoted. So this end is pivoted and this bar is kept on a horizontal surface and that surface is also frictionless, that is mu equals to 0. The mass of this bar is m and length is L. A ball is moving towards this bar and the velocity of this ball is perpendicular to the bar and it collides at a distance of L by 2 from the pivot. Mass of the ball is given, that is a small m, and velocity is also given, that is u. Now the collision between bar and the ball is an elastic collision. Now once this collision occurs, after the collision this bar starts rotating about this pivot and the angular speed by which this starts rotating is given and this is equals to omega, and the ball basically returns back in the same line, but the speed is different. This time a speed is v, initially it was u. So there is a change in velocity of the ball. We have to find what is the value of omega and what is the value of v. Basically 4 options are given and you have to choose the correct option. So let us try to solve this problem. Now we will consider two situations. First, before collision, and then I will also consider after collision. We have two unknowns, omega and v. So you need two equations. One equation can come from angular momentum conservation and other equation can come from elastic collision. Now let us see the torque. If you consider this pivot, a axis that is passing through this pivot, there is no torque about this axis because this system is kept on a horizontal surface. The torque of a weight will be in horizontal direction, but this axis is vertical, that is in this case this is perpendicular to the screen. So the torque of weight will not be in the direction of this axis, that is pivotal axis. This will be in horizontal direction and pivot itself is frictionless and it does not apply any torque. So I can say there is no torque that is acting in the vertical direction, that is direction perpendicular to the screen. We can apply angular momentum conservation. So let us write angular momentum conservation equation about this hinge or about this pivot. So we will first write angular momentum before the collision and then angular momentum after the collision. So before the collision this rod is in rest, so there is no angular momentum associated with this rod. So angular momentum is 0. Now this ball is moving. We know angular momentum about an axis is given by r cross mv. Just before the collision this ball will be somewhere here. So this means velocity is in this direction and radius is in this direction. So r cross mv will be basically coming out of this screen. Let's call this direction that is coming out of the screen is positive direction. So this turn will be positive. What will be the magnitude? R is L by 2, that is this, and u is u, m r cross mb, so mul by 2. What is the angular momentum after the collision? Now let us first write about this ball. For this ball is going in this direction. So again from this point I have to write r cross mb. So r is in this direction and v is in this direction. So r cross mb is basically going inside this screen. So that's why we should put a negative sign. And mass is given and v is given, so this will be mv L by 2 because this distance is again L by 2. So angular momentum of ball is this. And what is the angular momentum of this rod? So this rod is under pure rotation about this axis, that is this pivotal axis. So I can simply write angular momentum is equals to I times omega. And what is I about this axis? So I can use parallel axis theorem and then I can find I about this axis is ml square by 3. So this is a rod. For any given rod, angular momentum about the end is ml square by 3, that is I, times omega. And now this is again, the direction of angular momentum is again outside this screen. So this is coming away from the screen, or you can say coming towards you. So this means again this is positive. So now this is the angular momentum conservation equation. Let's call this is equation 1. Now we can write elastic collision equation. That is, in case of elastic collision we know that is velocity of approach is equals to velocity of separation. So initially this ball is approaching to this rod with velocity u. So this is velocity of approach. Now it is separating with velocity v in this direction, but what is the velocity in this direction? For this point, this is the omega and this distance is L by 2. So this point is basically moving in a circle of L by 2. So velocity will be L by 2 times omega in this direction. So L by 2 times omega in this direction and v in this direction. So what is velocity of separation? L by 2 times omega plus v. That is velocity of separation. Let's call this equation 2. Now we have written these two equations. We can solve for v and omega. So this is the first equation and this is the second equation. So what I can do is I can find v from this equation and plug in this equation. So this is the same thing, that is left side, and v will be u minus L by 2 times omega. So let us plug this value here, that is minus m and u minus L by 2 times omega times L, and this divided by 2. And this is ml square by 3 times omega. Now in the question mass is given, that is 0.1 kg, the mass of the ball, and this mass of this rod is 1 kg. So we can plug this value. So if I cancel, I will have this equation. So from here I can get relationship between u and omega. So this is u is equals to 43 by 12 omega times L, or omega equals to 12 by 43 L u. Now in the problem it is given that initial speed is 5 meter per second. So I can plug u equals to 5 and then I can get omega, that is basically 6.98 radian per second. Now from 2, if I plug the value of omega and u, I can get the value of v. So v equals to u minus L by 2 times omega, and u is 5, L is given, that is 0.2 and this is 2, and omega is 6.98. So from here we can calculate V, and the V will be 4.3 meter per second. So I hope you enjoyed this problem, and you can find many such kind of problem in which you can use this idea, that is conservation of angular momentum and conservation of energy, or you can use the same thing like velocity of approach is equals to velocity of separation, and you can solve for the two unknowns. I hope you like this video, and if you like, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.